Physics is a part of everyday life and is especially prevalent in car racing. Our first concept is how Newton's first law relates to car racing. Newton's first law states that an object in motion stays in motion unless acted upon by an outside force. Newton's first law is relevant when a car is moving in a straight path at a constant speed because it will maintain its course moving in a straight line unless an outside force acts upon it. For example, in car racing, if you put the car in neutral, the car will not coast endlessly because friction, which is an external force, acts as a force upon the car, which reduces the car's speed. The friction is produced by the tires as they create friction with the ground.
Our second concept is Newton's second law. Newton's second law explains that if a force is applied to a car, the force of the car divided by the mass of the car is proportional to the alternation in motion. The equation used in Newton's second law is F equals ma, where F is a force, m is the mass of the car, and a is the acceleration. This law also describes why fast cars are strong and weigh less.
For the next concept, we are explaining Newton's third law. The third law states that every force on a car by another object has an equal and opposite force. In this case, when the car crashes into another car, regardless of the weight of the other cars, each would exert the opposite and equal amount of force on each other. The directions of the forces are opposite. In another example, when you apply the brakes, you cause the tires to push forward against the ground, and the ground pushes back with an equal and opposite force.
For the next couple concepts, we're going to talk about power, torque, and work, and how they're all related to car racing. Many car race drivers find themselves being asked if they want their engine to have horsepower or torque. But what does this mean? Many people think that power and torque are the same thing, but they are different. Power is the rate of doing work and is dependent on torque. The equation for power is work divided by time. The units used to represent power are watts. For cars, instead of defining energy as power, they refer to it as horsepower. 750 watts is the same as 1 unit of horsepower. Torque is defined as an assessment of how much force is needed to rotate an object. The more torque a car has when turning, the less likely it is to slow down. To make a car faster, the more torque, the better, and the less mass, the better. Torque is measured in RPMs, which is revolutions per minute. In car racing, the more torque produced by an engine, the more work potential the car has. Work is a force that, when acting on another object, causes a displacement. Work transmits energy from one source to another.
For our next concept, we will be describing kinetic energy. Kinetic energy is the energy of motion. Every object that moves possesses kinetic energy. The faster the car is moving and the more the car weighs, the more kinetic energy the car has. If a car moves twice as fast as usual, it contains 4 times the energy. The equation is Ke equals 1/2 mv squared. Any car that is moving possesses kinetic energy.
For our next concept, we're going to talk about gravitational potential energy, or what we call GPE. On Earth, we always have the force of gravity acting upon us. When we're above the Earth's surface, we have potential energy. This is called gravitational potential energy. The amount of GPE an object on Earth has depends on its mass. GPE equals mass times gravity times height. There's also a direct relation between gravitational potential energy and the mass of an object. Cars with the bigger mass have a greater GPE. There's a connection between GPE and the height of an object as well. For instance, when a car is at the top of a mountain, it has the most GPE compared to at the bottom of the hill. Because the car is elevated, that means it has a greater GPE.
For a concept that has not been introduced in class, we chose to describe rolling resistance. Rolling resistance is the opposite of static and kinetic friction. Rolling friction applies to circular, deformable objects, like the tires on a car. Rolling resistance is a loss of energy. For example, when a car is moving, the tires are rolling, and the tires become deformed at the bottom. As the object deforms, it is losing energy, which can be seen as a frictional force that is called the rolling resistance.